In our previous lecture, we learned some terms of linear motion. Now, we'll derive some equations of motions. First of all, we have to know something like we will represent displacement. We will represent displacement as S or X. We will represent velocity as V as V. We'll represent acceleration as A, and we'll represent time as T. Here, another thing is, for initial velocity we will use V naught, and the final velocity we will use V. So it is initial and it is final. Same goes for displacement. For initial displacement we will use X naught or S naught, or final displacement we will use X or S. So if we know this for any kinds of problem, if we know this S, V naught, V, A or T, for in these 5 kinds of information, if we know three info, then we can solve the whole problem. So first of all, we derive some equation. The first equation is A equals to V naught plus sorry, not A, is V equals to V naught plus 80. This is our first equation. The second equation is S equals to V plus V naught divided by 2 into T. The third equation is S equals to Vt. The fourth equation is S equals to V naught T plus half of A T square. And the fifth equation is V square equals to V naught square plus 2A S. These are our 5 equations. By the help of these 5 equations, we can solve any kinds of motions problem. And to solve this, we need S, V, V naught, A, T. From these 5 information, we need any 3 information. The other information we can get through these 5 equations. So this is the 5 equation. This is the most important equations we have to learn. So first of all, these 5 equations we have to memorize it so that we can use that whenever we want. Now coming to the next part is graphs of motion. There are 2 types of graphs. One is S versus T graphs and other one is V versus T graphs. S means displacement versus time graphs, and the second one is velocity versus time graphs. So first of all, we discuss on S versus T graphs. In x-axis we will use time, and the y-axis we will use the displacement. If for S versus T graph, the slope determine the velocity. If the graphs for S versus graph, if the graphs is parallel to x-axis, then this is known as what should I say, no velocity. So as in change of time there is no displacement, so this is known as what should I say, this is known as no velocity. Means like the particle or the body is in no motion, we should say no motion. Here if this is the slope, this slope determine velocity, but it is also known as uniform velocity. But if the graphs is kind of like shaky, like these types of thing, this is known as non-uniform velocity. And when there is an elliptical graph like this, not give me some time, please paint it this as, if the graphs is look like this, then this known as acceleration. Acceleration. So by S versus T graphs, we know this kind of information by seeing this graphical representations or something like that. For now, if we talk about v versus t or velocity versus time graph, let give me some time to draw the velocity versus time graph. Okay, so we will now draw velocity versus time. In x-axis we will use time, and the y-axis we will use velocity. In the velocity versus time graphs or v versus t graph, the slope determines the acceleration or uniform acceleration. Uniform acceleration. If it is parallel to x-axis, this is known as uniform velocity. This is known as uniform velocity. If so this is the two types of graph that we do, another thing, if the acceleration is not uniform, for non-uniform acceleration the graph will look like that, or this is known as non-uniform acceleration. Another point is, by the help of v versus t graph, we can also determine the displacement, or we can also determine the distance. In v versus t graph, the area covered by these shapes is determined, the area covered these shapes determine the distance or displacement. So if I want to find out the displacement from O to P, then we will only find out the area of this graphical representation. If I want to find out the area from O to A, then we only have to find out this area. This area determines the displacement or the distance from O to A. So this is the graphical graphs of motions. We use two kinds of graphs. One is S versus T graphs or displacement versus time graphs, and the second one is V versus T graph or the velocity versus time graph. Now we will saw some laws of falling bodies, which is also known as Galileo's laws of falling body. The first law is, in a vacuum, all the freely falling bodies starting from the rest traverse equal distance at equal time intervals of time. So that means that in vacuum, if the room is vacuum, and if to a height h I throw two objects. One is a stone, one is a stone, and the other one is a paper. We know the stone is heavier than paper, but in a vacuum room, if I throw a stone and a paper, the two body will be travel same time the equal distance. Like these two body will touch the ground at time, same time. So this is known as the first law. So this is the first law. The second law states that starting from the velocity of a freely falling body is proportional to the time taken to fall it. So this is known as, for the freely falling body, like if I throw a not throw, if I free a stone from my hand, so this is known as freely falling body from an height h. So it says that the velocity of this stone will be proportional to the time taken to fall. So here from this we can derive an equation which is known as v1 by t1 equals to v2 by t2. So if I know V1, T1 and T2, I can find V2 also. So this is known as second law. What is third law? Third law is starting from rest, the distance traversed by a freely falling body is proportional to the square of the time to fall. So distance. So if the distance is h, and the time taken to fall this distance, like if I say that this is a h prime and time taken to come, this is not h prime, this is a h1, and time taken to come this h1 is t1. So we can say that h is proportional to t1 square. So h1 is proportional to t1 square. From that we can derive another equation which is equals to h1 by t1 square equals to h2 by t2 square. By the help of these two equations, we can solve many kinds of math problems. So the second and third law is very important for our math problem. We will remember or memorize these two formula. Now, coming to the second part, here we'll derive some equations of freely falling body. We know in previous we derived some equation. These equations are uh, the equations of motions are like first one is v equals to v naught plus at. The second one is uh, s equals to v plus v naught divided by 2 into t. The third one is s equals to v naught t plus half of at square. The fourth one is v square equals to v naught square plus 2g 2as. From these four equations, we only need these three equations: the this one, and this one. To represent freely falling body, we replace the displacement with h, the height. We replace the displacement s to h. We replace the a, acceleration a to g, the gravitational force, or uh, g, the gravitational acceleration. And we know for freely falling body from rest, the initial acceleration is equals to 0. So if I represent this three formula, we can represent as v equals to 8 and not 80, it will be gt. V equals to gt. The second one is h equals to this one, h equals to half of gt square, and the third one is v square equals to 2gh. So for the freely falling body, we will use these three equations. Now coming to the last part of our this linear motion lecture, the last part is equation of motion of a body thrown vertically upwards. Like if I throw a ball upwards, so what will be the equations of this ball throwing upwards? So these equations are, first equation is if I want to find out that we know an equation in our law of motion like v equals to v naught plus at. We represent this v naught equals v naught equals to v naught plus at as v equals to v naught minus gt for thrown vertically upwards. We know for the second equation is of our is equals to, we know h equals to v naught t plus half of gt square, and the third equation is v square equals to v naught square plus 2gh, and we replace these two equations as h equals to v naught t minus half of gt square, and the third one is v square equals to v naught square minus 2gh, as the force we applied to this particle upwards on the opposites of gravitational force, gravitations of g. So this whole plus sign will be replaced with minus, and the a will replace with gravitational force g, or gravity equals to g. So this is the three equation we'll get for the vertically upwards to throw when we throw a body vertically upwards. Here we can derive some more equations for this body thrown vertically upwards. Like these are, if I remove this thing and draw a concept like a body, I throw this body upwards with the velocity of v naught, and it go upwards here. Then this is the maximum height of this body. The time taken to travel it goes there and come there is actually t second, and the time taken to travel the maximum height, like this one is t second. Like one body is thrown, the body is moving to this point, to this point, this point to this point is t second, and total time to travel this whole system is like there it starts and there is come this capital T second. So if I want to find out the maximum height it gain, maximum height is, it will be equals to h equals to v naught square by 2g, v naught square by 2g. Now the time taken to reach maximum height, it is the small t equals to v naught by g, and the total time taken to go upwards and come downwards equals to, the total time equals to our total time is t equals to 2 v naught by g. So here I can also say that the time taken to go upwards equals to t1, and time taken to come downwards is t2, and t1 will be equals to t2. This also we have to remember. So there we learned some equations, we learned some equations of motion, we learned some equations of freely falling body, we learned some equations of body thrown vertically upwards. These equations are most important to in our next lecture when we solve some math problem. So we have to remember all these equations to solve a problem fast. That's all for today's video. We'll solve some problem in our next video. If you like this, if you love this video, please like this video and subscribe to our channel. Thank you.